Hello students, good morning to all of you. So today we will start with RLC series circuit. In previous lectures we have completed RL series circuit and RC series circuit. Now the topic of discussion will be RLC series circuit. And in this concept we will learn also about the resonance condition. So let me draw the circuit diagram. Here this will be your R, this will be your L, and this will be your capacitor. All these three elements are connected in series. Here single phase AC supply is applied, 230 volt, 50 hertz frequency, and here R, L, and C. So voltage across R will be VR, voltage across L will be VL, and voltage across C will be VC. And all these three elements are connected in series, therefore current will remain same. So if I will draw the phasor diagram, let me take current as a reference phasor. Here I will be the reference phasor. Now VR will be in the same phase, voltage across resistor will be same phase in the current. Now what will be the VL? VL will be 90 degree ahead from the current, this will be your VL, and VC will be 90 degree lagging from the current, so this will be your VC. Clear? So what will be the resultant? So resultant will be from here to here, VL minus VC. We can write here, we can write this portion is VL minus VC, only this portion. So overall the complete voltage will be equal to V under root VR square plus VL minus VC square. Okay, and as you know that values of VR will be equal to I into R, VL will be equal to I into XL, and VC will be equal to I into XC, where XL is equal to omega L equals to 2 pi F into L, and XC will be equal to 1 upon omega C. It means 1 upon 2 pi F into C. This will be your XC. Clear? So the value of voltage across VL across inductor and capacitor will depend on the value of inductor and capacitor. Now this will be your overall voltage. So from here, if I will multiply this whole with current, then what will happen? Or put the value of VR, VL, and VC. So I into R square plus I into XL minus I into XC square. It will become R square plus XL minus XC square. So here V is there. So I will be equal to V upon under root R square plus XL minus XC square. It is termed as Z, impedance. So Z will be equal to under root R square plus XL minus XC square. Clear? So if you will draw the impedance triangle, what will happen? Here it will be R, here it will be your XL minus XC, and here you will get the impedance. Here three conditions can be formed. First condition can be like XL is greater than XC. Second condition, XL is less than XC. And third condition, XL is equal to XC. This condition is called as a resonance condition. Clear? Now we have to discuss the power factor. Cos phi is equal to what? We have previously learned that cos phi will be equal to R upon Z. So R upon under root r square plus xl minus xc square. Similarly, what will be the tan phi? Here the angle is phi. Then tan phi will be equal to xl minus xc upon r. Here it will be your tan phi. And what will be the power consumed? As we have previously discussed that power will get consumed only in resistor. So power will be equal to Vi cos phi, okay, or I square R, or V square by R. Yeah, so it will be the significance of all the parameters. Here at the place of Vi we can represent like S cos phi, where S is what? S is termed as apparent power. Apparent power. P is what? Active power. Yeah. So let us discuss one or more numericals and then we will proceed further with the resonance condition. So question is like, in a AC circuit, voltage is given 230 volt, frequency is given 50 hertz, L is given 0.06 Henry, R is given 2.5 ohm, and C is given 6.8 microfarad. Here we have to calculate impedance Z, then current, then phase angle. It means phi we have to calculate, and then we will calculate the angle, then power factor, and then power consumed. We have to calculate all these parameters for this question. So what we will do, first of all calculate XL. XL will be equal to 2 pi FL. Put the value 2 into pi into f is given 50 hertz into L is given 0.06 Henry. So what will be the value of XL? 18.84 ohm. Now calculate XC, 1 upon 2 pi FC. Put the value 1 upon 2 into pi into 50 into C is what? C is given 6.8 microfarad into 10 to the power minus 6. So the value will be 468 ohm. Now, as you can see that XC is greater, XC is greater as compared to XL. So value will get negative. Now, what is impedance? Z will be equal to under root R square plus XL minus XC square. At this place, we can also write like R square plus XC minus XL square. Clear? There is no problem. The value which is greater, we can use that value at the first. So put the value and we will get result. What is the value of R? R is 2.5 ohm. 2.5 square plus what is XL? Sorry, XC. 468 minus 18.84 will be in square. So on solving, we will get 449.2 ohm. This will be your Z impedance. Now what will be the current? Current I will be equal to V by Z. What is V? V is given 230 volt upon 449.2. So the result will come like 0.512 ampere. Clear? Now next is what? We have to calculate tan phi. Tan phi will be equal to, either you can use XL minus XC upon R, or you can use XC minus XL upon R. So it will come tan phi equal to, so phi will be equal to 89.7 degree. Here now next what we have to calculate? Next we have to calculate cos phi. So cos phi will be equal to what? R by Z. So what is R? 2.5. And what is Z? We have calculated Z is equal to 449.2. So the value will be, what will be cos phi? Cos phi will be 0.0056. And what will be the nature of this 0.0056? It will be leading, because capacitive impedance is more as compared to inductive reactance. Clear? So effect of capacitive is more as compared to inductive effect. So the circuit will be leading, the current will be leading. And what will be the power consumed? Power consumed will be P equal to VI cos phi. V is what? 230 volt multiplied by current. We have calculated 0.512 ampere multiplied by power factor. Power factor is what? 0.0056. So power consumed will be equal to 0.66 watt. So it was the basic concept of RLC series circuit. Here now we will move further with one more question. What is given? Let's take one more question. It is given R is given. It is written as a resistor R, an inductor L, and a capacitor are connected in series. When an alternating voltage of V value is given is applied to the series combination, the current flow is value is given. Find the value of R and C. It means it is saying that R, L, and C, these three elements are connected in series with a AC voltage. So, and the voltage is 400 sine 3000 T minus 20 degree, and the value of current that is flowing, I is equal to 10 root 2 sine 3000 T minus 45 degree. Here it is 65, sorry. This is current, and the value of inductor L is given 0.01 Henry. We have to find the value of R and the value of C. These two parameters we have to find. Here from this value of voltage and current, we can see that omega is given 3000 Omega is equal to what? 2 pi f. 2 pi f is given to 3000. Then f will be equal to 3000 upon 2 into pi. Clear? Well, although we have no need to find this frequency because xl is equal to omega L, xc is equal to 1 upon omega c, direct we can use the value of omega. Here you can find, on solving, you can find the value of 1500 upon pi, the value of frequency. Here, next, from these two values, let me draw the value of voltage. Suppose this is your reference phasor and this is reference. Voltage is given as sine omega t minus 20 degree. So voltage is 20 degree lagging. This will be your voltage and the difference is 20 degree. Clear? And in the current is written, current is lagging sine omega t minus 65 degree. From reference phasor, current is lagging 65 degree. This angle is what? 65 degree. So overall this angle will be what? This angle will be 65 minus 20 equals to 45 degree. So basically the phase angle between voltage and current, phase angle between V and I will be equal to what? 45 degree only. Clear? Let's move further. Let me first calculate XL. XL will be what? Omega into L. Omega is what? 3000 into L is what? 0.01. So here you can get 30 ohm. This is the value of XL. Now, as we know that tan phi will be equal to XL minus XC upon R here, and what is the value of tan phi? Phi is, we have calculated here, phi is 45 degree. So tan 45 will be equal to XL minus XC upon R. It will be 1 XL minus XC upon R. So basically R will be equal to XL minus XC, and R is equal to XL is what? 30 minus XC. Here we have our first equation. Clear? Now what will be the value of Z? Z will be equal to V upon I. So what is V? From this equation we can see that V is equal to 400 sine 3000 t minus 20, and what is current? 10 root 2 sine 3000 t minus 65. So basically the magnitude of V is 400 and magnitude of current is 10 root 2. So it will become 40 root 2 or 20 root 2. Z will be equal to 20 root 2. Now, what will be the value of Z? Z equal to under root R square plus XL minus XC square. So Z square will be equal to R square plus XL minus XC square. Here from this equation, look here, from this part you can write R equal to XL minus XC. So at the place of this XL minus XC, what I can write? I can write R. So R square plus R square. So it will, Z square will be equal to 2R square. So Z will be equal to root 2 into R, and R will be equal to Z upon root 2. So what is Z? We have previously calculated Z is equal to 20 root 2, 20 root 2 upon root 2. So R will be equal to 20 ohm. This is clear. Now put this value of R here. 20 equal to 30 minus XC. So XC will be equal to 10 ohm. We have calculated yet only XC. Still we have to calculate C. So Xc will be equal to 1 upon 2 pi fc or 1 upon omega c. So what will be the value of C? C will be equal to 1 upon omega into xc. So 1 upon omega is what? 3000. What is xc? Xc is 10. So it will become, so the value of capacitance will become, C will be equal to 33.3 microfarad. We have to calculate these two values and we have successfully calculated the value of R and C. Clear? Okay, thank you. So in next lecture I will start with the resonance condition. We will complete this part. Thank you.